Let's talk about using logarithms to solve exponential equations now. Sometimes when we're dealing with exponential equations, we can't use this one-to-one property because we don't have the same base. So what we can do then is we can use logarithms and specifically everyone's favorite Yeat theorem to get the variable out of the exponent. Here's how we do that. Let's say we have two exponential functions that are set equal to each other, but they have different bases. Well, in this case, we can take a logarithm, any logarithm of both sides, as long as those logarithms have the same base. And then our Yeat theorem says we take the exponent and yeet it right in front, and we're going to do that for both sides. At this point, log A is just a number, and log B is just a different number. And so we can then turn this exponential equation into a linear equation to solve for x. Let's give this a shot. We have 3 to the x equals 7 to the x plus 1, and there's no easy way to write 7 as powers of 3. And so what we can do is we can take the logarithm of both sides. It doesn't matter what logarithm we use. We can use a log base 10 or a log base e. In fact, there's a special case where we use a log base 7 or a log base 3. But ultimately, it doesn't matter which one we use. So we could do log of 3 to the x equals log of 7 to the x plus 1. Here I'm just using our common log with base 10. At this point, we'll use our Yeat theorem to take our exponents and throw it in front, taking the entire exponent in front, giving us x log 3 equals the whole thing, x plus 1 log 7. And remember, these are just numbers. If we expand this a little bit, x log 3 equals x log 7 plus 1 log 7. Again, just a number. And now we can collect our like terms, bringing all the x's on one side. X log 3 minus x log 7 is just our number log 7. We can double check what that is in just a moment. And then finally, we can factor out an x, giving us log 3 minus log 7 equals log 7 once again. So if we want to solve for x, we can divide both sides by log 3 minus log 7. Same thing over here. And at this point, we have something being multiplied and divided in the numerator and denominator. And so we're left with the solution x equals log 7 divided by log 3 minus log 7. And we could type that into our calculator. Notably, I used a log with base 10 for these calculations, but a log with any other base would also give the same answer once we type it into our calculator. Try it for yourself. If you use a log with base 7, you'll see that some of the algebra simplifies a little nicer in some cases.